It turns out that the lazy variant of curly we just implemented isn't lazy enough. This example demonstrates why. So here's a function that takes an argument x, and it uses x 4 times. So when we provide this argument, this largish expression, as the argument to x, it gets delayed and bound in the environment to a thunk, and then every time that x is referenced, that thunk is interpreted. So we end up evaluating this big expression 4 times. Since it's a functional language, since curly is functional, we would really like to evaluate it only once. That is, we want to be lazy in the sense of waiting until x is needed to evaluate it, but once we've evaluated that expression, we don't want to re-evaluate it because the result is going to be the same every time. It turns out these redundant evaluations in our current lazy interpreter can create real problems depending on your program. I have an extra test case here that I have commented out before. It defines a function x2 that just takes an argument and uses it twice. x4 passes the result of x2 to itself. That means it turns out it does 4 additions. And when we do this again, applying x4 to the result of itself, we do something 16 times, 256 times, and so on. When we run our program with this test case uncommented out, it takes far too long. And a little expression like this should not take a whole second to run. So the problem again is that we're doing redundant evaluation. We're not lazy enough. And the way we can avoid the redundancy is remembering the result that we get the first time we interpret it. So that means we need to change our thunk to have an extra field. It's going to have the argument expression and the environment. We need those pieces to interpret, but we're going to add an extra field which is a done field. And this is a box of option of value. And that way we have a box that we can change to put in a value after we have done the calculation. So when we create a delay, we start out with a box that has none inside because it hasn't been interpreted yet. And then we change the force function to, instead of having 2 fields to look at and always call interp, we will have 3 fields: the expression, the environment, and a box that has the value if we've already computed it. So the way force should work is it should look inside that box. If it doesn't find a value there yet, it should do the interp as before. But this time, before returning that value right away, it should store that value inside the box that's inside the delay. That way, next time, when the same thunk comes in, we will find a sum there with the value that we computed before. This change is implemented in our more lazy interpreter, which has the same test in it. And this time we run the tests. Then we find it takes a very small amount of time. And the key again was changing our thunk implementation to record the value that's inside of it, and changing the force function to remember that value after it's computed.